L'Hopital rule. When you have an indeterminate limit such as 0 over 0 or infinity over infinity, that's when you can apply L'Hopital. Example, limit as x approaches to 0 of sine x over x. Now, let's think back in the beginning of the semester when we take the limit by definition, we learned that sine x over x is simply equal to 1. Now, using L'Hopital, we can prove that. So if you plug in 0, you end up with the sine of x, sine of 0 over 0, which is 0 over 0. This is where you go, all right, if you have a 0 over 0 situation, when you simply plug in your at the limit as x approaches 0, this is where you can use L'Hopital. So we're going to take the derivative of the top and derivative of the bottom. Derivative of sine become cosine, derivative of x equal to 1. Then we plug in 0 one more time. Then we get 1 over 1, which is 1. So therefore, limit as x approaches to 0 of sine x over x equal to 1. All right, same thing. Let's look at example 2. If we go ahead and plug in 0 right now, so 2 times 0 minus sine of 0 over 0, this will get you a 0 over 0 situation again. So we're going to apply L'Hopital. Then take the derivative of the denominator. You get 2 minus cosine x. Take the derivative of the numerator, and take the derivative of the denominator, which is 1. Now, once again, if we take we plug in x equal to 0, you get 2 2 minus 1 over 1, which is equal to 1. So let's look at example number 3. When we apply, when limit as x approaches to 0 of square root of 4 plus x minus 2 over 2x, if you go ahead and plug in 0 right now, then you will have square root of 4, which is 2 minus 2. So that will give you the numerator equal to 0. And when you plug in 0 into the denominator, you also get a 0. So once again, you have a 0 over 0 situation. This is where you can apply L'Hopital. So when you apply L'Hopital, you take the derivative of the top, you get 1 over 2 times square root of 4 plus x, divide by, and derivative of the denominator will get you 2. Now, once again, now if you now go ahead apply 0, but let this new function as x approaches 0, you plug in 0 here, you get 1 over 4 divided by 2, so equal to 1 over 8. Now let's look at some examples where x approaches infinity. If you let this function let x equal to infinity, then we learn that the answer should be 5/3. But now let's use L'Hopital to prove it. If you use L'Hopital, the derivative of the numerator it give you 5, then the derivative of the denominator give you the 3. So limit as x approaches infinity of 5/3 is simply equal to 5/3. Okay, now example 5. So this L'Hopital also works with trigonometry as well. So if you look at our trig functions, if we let x equal to pi over 2 into x secant pi over 2 and 1 plus secant pi over 2. In this case, you're going to get a L'Hopital situation. So then what do we need to do? If it's 0 over 0, okay, or infinity over infinity, okay, then we need to what? We need to take the derivative of secant, so that's secant tangent, and derivative of 1 plus secant x equal to secant tangent. Now notice secant tangent over secant tangent just simply equal to 1. So now before, if you just do a direct plugging in, you wouldn't be able to find a derivative, okay? But once you have, using L'Hopital, you can simplify this into 1. Okay. Now notice, okay, if look at the original equation here for this next example. Limit as x approaches 0 from above, x cotangent x. If you plug in 0, it's 0 times infinity. Now 0 times infinity is not a L'Hopital case. L'Hopital says it has to be either 0 over 0 or infinity over infinity. So what we need to do is change it, instead of cotangent, change it to 1 over tangent. So if you do that, now become limit as x approaches 0 of x over tangent x. Now if you plug in 0, you get 0 over 0. Now this function here, instead of x times cotangent x, if you change to x over tangent x, this is the L'Hopital case. So if you go ahead and apply L'Hopital, you get 1 over secant squared. Then once you plug in 0 again, then you get 1 over 1, which is equal to 1. Okay, now we're looking at this last example here. So limit, okay, again, if you go ahead plug in 0, you're going to get 0 over 0. So what happened is we're going to take the derivative. Okay, so when you take the derivative, you get the top the numerator is 1 over 2 to the square root of 4 plus x minus 1/4, and the denominator is 4x. Now the problem is if you plug in 0, you still get 0 over 0. That means what? But since it's still a 0 over 0, you can apply L'Hopital the second time. You can apply L'Hopital as many times as you want, as long as your ending expression is 0 over 0 or infinity over infinity. So we're going to take the L'Hopital one more time, take the derivative of the top and bottom separately again. You get this new function here. But this time when you plug in 0, you'll be okay. You're actually going to get a number now. So this is a negative 1 over 32 over 4, which is equal to negative 1 over 128.